Alright, so imagine you're a senior engineer who has been reviewing a junior engineer's PR for the last 20 minutes. It's a big PR, but somehow you get through it, only to realize at the very end that they didn't create types for some objects. You ask them to do it, they come back after an hour with an updated PR, you approve it, but just to check if everything works as expected, you run the test locally from their branch, and guess what? They fail. You get it fixed by the engineer and all of it now looks good after 3 hours of back and forth with the engineer. One more scenario. Imagine you again are reviewing a PR which has 4 files. Good enough. But in these 4 files, 90% of the lines have been modified. You ask the developer who raised this PR why they changed so much of the code in those 4 files, and they say all those 4 files have is like 1 line changes. So then you take a closer look only to realize the formatting changed and now the diff that GitHub generates looks like a war zone. This happened because all the engineers in the team, they do use Prettier, but they have their own local config. Whatever rules they have in their local VS Code, that is going to be applied to the files. So if someone else does not use those configurations, like say for instance, one engineer uses a ESLint rule for double quotes. There's one more engineer who instead of double quotes uses single quotes. There is a specific rule in ESLint for this. So anytime one of these guys raise a PR, the main branch is going to now change from single quotes to double quotes or double quotes to single quotes. The next time the other engineer raises a PR, they are going to change all of it again. So even though the actual change might be very minimal, because of this ESLint rule, it's going to refactor the entire file or whatever files that are being committed. So this is going to be a major problem. One final scenario. Imagine something broke in production and you are part of a small team. This team commits multiple times on a daily basis. Now you have to go through the commit history to see where exactly the code broke the application. And the moment you open the git commit log, you see this.
What are you doing? What are you doing?
Now all of these scenarios are very common in startups and sometimes even in huge MNCs where no standards are set. All these so-called standards come under Git automation, and over the next couple of videos, we will set up a solid Git workflow that saves a lot of time and energy for the entire team. I'll take you through tools that have been battle tested and are being used by all the mangs of the world. We're going to solve a set of very common problems using Git automation. Essentially, it is going to first format and lint our code before every commit. Now this is only going to happen on staged files to save time, and it also becomes quicker because if you format and lint your local code every time, it's going to take up unnecessary memory and it's also going to slow down the entire development process. You don't even need to do that, to be very honest. All you have to do is lint and format the staged files before you commit. Because that is what matters, right? Whatever you push to the central repository, that should be of a specific format across the team. So the project itself will have that configuration, and that way everyone will follow that one particular structure. No one is going to get unnecessary changes in their PRs. They'll all see only the content that has been changed. So formatting and linting is part 1. The second one is blocking the commits that fail tests or type checks. So if an engineer A, for instance, has updated something in one module and that for some reason is now breaking a test in another module, they won't come to know that, to be very honest, until and unless they run the test themselves. And a lot of times people don't do that. So the moment they try to commit, it is going to run all the tests once before this is committed to the repository. And if a test breaks somewhere, then it's not going to go through. It's going to break that workflow and you won't be able to commit to the repository. The second one is type checks. So say for instance, you have a huge type that is being used throughout the application. There are like 24 instances where you have used this TypeScript type. Now for whatever reason in the future, one of the keys inside that type, the type of that key changes. Now if this key is like a very important part of this type and it's being used wherever this type is being imported, then it's going to be a challenge for the engineer to fix it everywhere. Let's say they forget to fix 1 or 2 instances in like 1 or 2 files. This is also going to be picked up by the Git automation workflow that we are going to build. So if there's like an invalid usage of a particular type, it is also going to be picked up by this workflow. That is part 2. So formatting and linting is part 1. Blocking failed tests and type checks will be part 2. Part 3 will basically ensure following a structured format for commit messages. So the problem that we just looked at, unnecessary random commit messages that don't really help anyone, we are going to solve that with the help of 2 libraries, that's Commitizen and Commitlint. Again, here to be very honest, if you want to still push irrelevant comments, you can do it, but it's going to build a habit for you and for all the engineers in your team, and eventually you by default won't put out stupid comments. You will actually try to make sense, and these libraries are going to help you build that habit. Part 4 is going to deal with changelogs and version bumps. So let's say for instance you have a monorepo setup wherein inside that monorepo there's one package that is being reused across other packages. So in that case, you obviously have to maintain the version for that package and also continuously update the changelog so that everyone else knows exactly what's being updated with each version. This again normally is a manual process, but we are going to automate this with the help of a package called chainsets. So here we'll also be using GitHub Actions because this is automation after committing. So once you have committed and once you have raised a PR, which is now going to go to the main branch, that is when it's going to automatically update the changelog first and then update the version of the package as well. So this is automation after committing, but it's still part of Git automation. We'll cover this in the 4th or the 5th video. I'll also go through the tools that we're going to use to achieve this. Husky is the first tool that is actually going to let me define Git hooks. So there are like multiple hooks, for instance, pre-commit, pre-push, commit message. All of these hooks run at a particular point in the Git lifecycle. So just by the name, you can understand that pre-commit is going to run right before you commit something to Git. So all of these steps that we just discussed, formatting and linting, blocking failed tests and type checks, all of this is going to be part of pre-commit. Commit message is a hook that is going to handle the chain sets, change log, all of that. So again, this may not make sense to you right now, but I'm just taking you through what all tools we'll be using. So if you want to learn a specific tool, you can just directly hop on to that video and see how it works. So Husky is the primary tool that we are going to use for Git hooks. Then we have lint staged. So we are only going to lint the files that are staged because it's faster. Then Commitlint and Commitizen is going to enforce commit messages in a particular format. So there's this standard called conventional commits. We are going to follow that standard and we are going to achieve that with the help of Commitlint, Commitizen and tools around these packages. Then the final package, which is chainsets, is what we'll be using to manage semantic versioning and auto-generate changelogs. All of this will make a lot more sense when you watch the actual video, wherein I'll cover these individual packages in extreme detail. So yeah, essentially the goal is to never forget a test, break formatting, or release inconsistently ever again. I personally work with similar setups on large-scale projects with dozens of contributors. Once it's in place, your team just writes code and the system handles the rest. It actually becomes normal very quickly. And later on, when you work on repositories that don't have these automation tools in place, you realize how much time they were actually saving. So yeah, this is going to be a fun one. All these tools are somewhat complex, to be very honest, and this may not feel like a beginner friendly tutorial, but I'll try to keep it as simple as possible. And I'll take you through real world scenarios, which I hope would make sense to you and make you realize why these tools are necessary. Anyway, we are not really going to do any development throughout this series. All of it is related to configuration and how to set up these steps in your workflow. So yeah, in the next video, we'll start with the initial setup. If you're new to this channel, do subscribe and I'll see you in the next one.